And now it's time for some homework problems from week 8. First one I randomly chose is question number 1. It will be similar to this, where basically they're saying that they went ahead and did the power rule. So they put the 7 in front, multiplied, subtract 1. So they did that part. And then the chain rule says now you need to take the derivative of the inside, and that's what goes right here for the question mark. Well, the derivative of 5 is 0, and when you take the derivative of this, the 2 will go down in front and multiply, which is going to be negative 12. And then when you subtract 1 from the exponent, it's going to be negative 12x. So that one is done. Then for number 3. So number 3 is very similar, but I just thought this looks sort of strange, but it is really just the same thing. It's just the placement of this question mark is sort of weird. So anyway, it should be times, and then basically they should have had something like this, times what? So the derivative of natural log is 1 divided by whatever's in the parentheses. So they did the derivative of the natural log, and then take the derivative of the inside. So when you do the power rule right here, the 5 goes in front, subtract 1 from the exponent, and that one's finished. On to, next up, I chose number 8. So number 8 is find the derivative, and then also find the equation of the tangent line. So there's 2 things we need to do. Yes, find the derivative, but then I also need to plug in the 2 so I can find out what y equals. So basically I'm going to do that right now. So if I plug in a 2, the y value will equal 12 times 2 minus 8, and then that's to the 1/2 power. So this is going to be 24 minus 8, and 24 minus 8 is 16. And then the 1/2 power means take the square root, and the square root of 16 is 4. So in other words, the point they're talking about is when x equals 2 and y equals 4. So that's some algebra that I needed to do before even taking the derivative. Now take the derivative. So f prime equals, so again using the power rule, take the 1/2, put it in front and multiply. And for right now, the 12x minus 8 just stays there. And then subtract 1 from the exponent. And a 1/2 minus 1 will be a negative 1/2. And now for the chain rule. So take the derivative of this 12x minus 8. And the derivative of 12x is 12. And personally, I don't like negative exponents, so I'm going to simplify this thing by putting the 12x minus 8 to the 1/2 in the denominator. That gets rid of the negative exponent. And then, as you can see with my red pen, I can simplify because 2 will divide into 12 6 times. So that is the derivative. And then we need to substitute the 2. So then when you substitute a 2, it's going to be 6 over 12 times 2 minus 8 to the 1/2. And I actually did that right here, so I know that that part's supposed to be a 4 on the bottom. So then it's 6 divided by 4. And then I want to reduce that fraction, so divide by 2 and divide by 2, and it could be reduced to be at 3/2. Then find the equation of the tangent line. So using the point slope formula, it goes y minus the y value of 4 equals the slope times x minus the x value of 2. And then I need to solve for y. So distribute this 3/2 And on the right side, it's going to have 3 halves x. And when you multiply this 3 halves by the 2's are going to cancel. It's just going to leave a negative 3. And then the last step to solve for y is just add 4 to both sides. And so my answer for the tangent line is y equals 3 halves x, and then this would leave a plus 1. And then before we go on to the next one, they also said find the values of x where the tangent line is horizontal. So they're not asking you about this one, but they're saying go back to the derivative. Horizontal means that the slope equals 0. So for this second question here, they're saying take the derivative and set it equal to 0. And the only way a fraction equals 0 is if the top equals 0. But for this particular problem, the top cannot equal 0 because a 6 never equals 0. So this one has no solutions. Okay, then on to the next example, number 11. The reason I chose this one is not only do we get to do the product rule and the chain rule, but again, horizontal tangent line means when does the derivative equal 0? So for this one, we need to use the product rule. So that means take the derivative of the first one. They already said f prime equals, so I'm just going to write the derivative. So take the derivative of x to the 7th, which is 7x to the 6th. And then just copy down x minus 12 to the 5th, so that one gets left alone. Next, the product rule goes plus. Now leave x to the 7th alone and take the derivative of this function. So the 5 will go in front and multiply. The x minus 12 stays the same. Subtract 1 from the exponent, and so now this is a 4. And then technically you would do the chain rule and take the derivative of x, which is a 1, and then multiply by a 1. And then set it equal to 0. So 0 equals, and in order to solve this, I need to factor. So this has x to the 6 and this has x to the 7. So that means I can factor out x to the 6th. This has an x minus 12 and this has an x minus 12. And whatever the smallest exponent is, that's what you can factor out. So I can factor out x minus 12 to the 4. And then what remains? So this got factored out, x to the 6th, but the 7 did not, so there's still a 7. And for the x minus 12, I took out 4 of them, but 1 of them would remain. And then it goes plus. So this x minus 12 to the 4 got factored out. The 5 did not. And 6 of these got factored out, which means there's still an x times a 5. Okay, now that it's factored, we're almost done. Now just set each factor equal to 0. So basically taking one difficult problem and separating it into 3 easier problems. And then for this one, I'm going to go ahead and distribute right now. So this is going to be 7x plus 5x is 12x. And then 7 times 12, I believe that's 84, but I want to double check. 7 times 12 is 84. Okay, then for this one, you could take the 6th root of both sides, and that is going to get rid of the 6th power. So take the 6th root and take the 6th root. And so the 6th root of 0 is just 0. So there's one answer. On this one, you can do the 4th root of both sides. That's going to leave x minus 12 equals 0. And then just add 12 to both sides, and x equals 12 is a second answer. And for this one, add 84 to both sides. And then divide. And since it was 7 times 12 that gave us the 84, when you divide both sides by 12, that's going to be a 7. And then, so you would put the derivative and probably in simplified form. And then after that, they would say, what are your answers for x? And they would probably say, separate your answers with a comma. So then you just put it like this. And then some implicit differentiation. Going on to question number 19. So find the derivative and then evaluate the derivative. So plug in x is a 2 and y is a 0. So first of all, on the left side, when you take the derivative of the e function, that is the e function. And then because of the chain rule, you do need to take the derivative of y, so it's going to be times y prime. On this side, do the power rule, so that's going to be 3x squared. And right here, also do the power rule, so the 5 goes in front, and then subtract 1 from the exponent, and now it's to the 4th. And then do the chain rule, so take the derivative of y, so that's y prime. Now notice right here, it says you do need to solve for y prime, put what y prime equals. So that means I need to put everything on one side. So I'm going to take this and add it to the other side so that all of the terms with y prime are going to be on one side. And so on this side, this has y prime and this has y prime, so I could factor out y prime. And then what remains is an 8 e to the y, and then plus a 5y to the 4th. And then after you have these cancel, on the right side there's only the positive 3x squared. And then the last step to solve for y prime is just divide. So the right side already had 3x squared, and then divide by this. And then that is what they're asking for right here. Next, plug in a 2 for x and a 0 for y. So this is going to be 3, and then plug in a 2 for x and a 0 for y. And how much does that equal? Well, this is going to be a 4 times 3, so that's 12. This is going to be a 0, and then e to the 0 equals 1. So this is going to be 8 times 1, so then it's 12 divided by 8. And then this should be reduced. You can divide this by 4, and you could divide this by 4. Oops. I was talking at the same time. Hold on. You can divide this by 4 and divide this by 4. When you divide 12 by 4, that's known as 3. And when you divide 8 by 4, that's 3 over 2. And let's see what else. So this one is basically the same thing, except they're saying find x prime. So what that means is we're taking the derivative of x with respect to t. So basically x is the function and t is the variable. And they said they're going in the order that t goes first. So this is t and this is x. Okay, so when you take the derivative for x squared, you do the power rule first, that's 2x. And then take the derivative of x, so that's x prime. Plus, so this middle part right there, that's going to be the product rule. So take the derivative of the first one. The derivative of t squared is 2t. And if you did the t prime, that would mean you have dt over dt, so it's a 1. So you could multiply by 1 if you want to, but it's not going to change the answer. The rest of the product rule goes leave x alone, and then go plus. This time, leave t squared alone, and take the derivative of x, which is x prime. Next up, the derivative of t to the 6th. So then that's going to be plus 6t to the 5th. And then the derivative of a negative 3 is 0, and the derivative of that 0 is 0. So it equals 0. And like the last one, we need to solve for x prime. So anything that has an x prime needs to be on one side. The things that don't have x prime need to be moved to the other side. So on the right side, I would subtract this, so it becomes negative 6t to the 5th. I'd also need to subtract this to move it to the right side, so minus 2t times x. And now on the left side, this has x prime and this has x prime, so I could factor out x prime. When I factor out the x prime, this is just going to be a 2x. When I factor out this x prime, it leaves plus t squared. And then the last step to solve for x prime is just divide. So on the right side, there was already the negative 6t to the 5th minus 2tx, and then divide by 2x plus t squared. And then just like on the last one, plug in these numbers after you've done the simplifying and solve for x prime. So one, they ask for the derivative x prime itself, so that's the first answer. And then plug in the negative 1 and the negative 2, and then that's going to be this answer. But I do have some other examples that I want to get to. So next, number 24. So the demand X is the number of items that could be sold for a price P. Find the rate of change. So right there, they're saying derivative. Find the derivative of P with respect to X. So they're saying find the derivative of the P. So that goes on top. With respect to means this goes on bottom. So it's very much like dy dx, except they're not using y, they're using P. So take the derivative on the left side. So that would say dx over dx, so the derivative of x is 1. And then move over to the right side and use the power rule, so that's going to be 4p cubed, and then times dp dx, or you can use p prime for short. And then move on to this one. So when you bring the 2 down and multiply, that's going to say minus 6 times p to the 1, and then times the p prime. And the derivative of 1500 is 0, so I don't need to put plus 0. And like on the last two problems, the p prime is showing up in 2 places. And so I can factor out p prime. That's going to leave 4p cubed minus 3p. And then this just has the 1. And then finally, to solve for p prime, just divide both sides by this thing. So the p prime would stay on the right. On the left, there's 1 divided by 4p cubed minus 3p. So find the rate of change. And so they're only asking for the derivative on this one. We don't have to plug in any numbers. And next up, a point is moving on the graph x times y equals 21. When the x coordinate is increasing by 7 units per second. So that means that second, that's going to be time. I'll use t. And so basically all of this part is saying that dx dt equals a 7. How fast, that means derivative, is the y coordinate changing? So they're saying find the derivative of the y with respect to t. And then I guess they might have like a multiple choice box right here. Okay, so we go to the function and take the derivative. And because it's derivative with respect to time, every time we take the derivative of one of these variables, we're going to get either an x prime or a y prime. So this is going to be the product rule. So take the derivative of x is x prime, and then leave y alone. Plus, leave x alone, and now take derivative of y, which is y prime. And on the right side, the derivative of 21 is 0. So this is telling us to plug in the 7 for the x prime. It's saying that x equals 7 and y equals 3 right here. So plug in that the x prime is 7, the y is a 3, the x is a 7, and then solve for y prime. So this is 21, so I can subtract 21 from both sides. And then it's going to leave 7 times y prime equals negative 21. And then when you divide by 7, it's going to be negative 21 divided by 7. And then that would be negative 3. And then whatever the units are, by this they mean something like feet or inches, but they're just calling it units. So it's negative 3 units per second. And then just one more, and believe it or not, this is the same problem. So Boyle's law for enclosed gases, so if you have something like a soda can and it's got gas in it, if the volume is kept constant, so in other words, the soda can stays a soda can, so the volume is not going to change, the pressure and temperature are related by this equation. So if you take a soda can and then you put it in like 200-degree water, so if you increase the temperature, then the pressure is going to increase. I do not recommend you do this. Don't go to the kitchen right now with the soda can and go try to boil it. It's going to make a mess. But anyway, that's what they're talking about. So the P is the pressure, the T is the temperature, and the K is a constant. So this is very similar to the last problem, except the last problem we had to do the product rule. This one is going to be the quotient rule. So if the temperature is increasing, so this means something is changing, so that means the derivative. So this part is saying that the derivative of the temperature is 4 kelvins per hour. What is the rate? So what is the derivative of the, so it's saying find P prime. When the temperature, so that's when T equals 300 kelvins, and the pressure, the P, is 900 pounds per square inch. Okay, that's a lot of information. So over here, we need to take the derivative. On the left side, we need to use the quotient rule. So I was just thinking they want us to use the quotient rule, but if we multiply both sides by t, wouldn't that make the problem simpler? I think it would. So we would have P equals K times T. Yeah, that's simpler. Let's do that. Now the thing is, they didn't tell us what K is. but they are telling us what t is and what p is. So before I take the derivative, I'm going to do this algebra part so I could figure out what k equals. So they're saying if you plug in a 900 for the pressure and 300 for the temperature, then you could solve for k. So all I need to do to solve for k is divide both sides by 300. All these zeros are going to cancel, and it turns out that k is a 9 divided by 3, so k equals a 3. So now I can just go back to this equation and plug in a 3. So P is equal to k times T. Okay, I just found out that k equals 3, and I forgot to write that down as I was talking, so there it is. And then when you take the derivative, because 3 is a constant, you don't even have to do the product rule. All you have to do is say, take the derivative on this side, take the derivative on this side. And then it said, find the derivative of p if the derivative of t is 4. So the derivative of p equals 3 times 4, and then that's 12. All right, there we go.